Welcome back, guys, to maths lesson number 5. Today what we're going to be looking at is finding the missing lengths, whether it's the height, the radius, or maybe the slant height. So what we're going to do is I want you to pop over as far as page number 83, okay? Starting on exercise 4.1. Now guys, if you want, because you're well able to do these yourselves, okay? So you have the ability to do these because what we did in the previous lesson was learn how to fill in the formula. So if you do want to take a second and actually try the next ones, 4.1 and 4.2, do, okay? So you are well able, and then come back to the video maybe and have a look. Now, we're going to start on 4.1, so make sure you have the question out in front of you. I'm going to read through it really carefully, and I want you to highlight a couple of things. They say, find the highlight the word volume, highlight sphere, and highlight 972 pi centimeters cubed. Now, first thing I'm going to do here, and I would advise you just to jot it down on the side of page 83. They're talking about a sphere. Okay, so here is my sphere. So this is my sphere. Normally we know the radius, I can't see that, okay? But I do know the volume of the sphere, as they've said to me, is 972 pi centimeters cubed. Now, usually that's actually what we would go and try to find. But in this case, they've seemed to given us the answer, okay? So what are they going to ask us? Part number 1, highlight the word length and highlight radius. So they're asking me in part number 1 to find the length of the radius. Now, to start off here, here's my radius. My radius is the distance from the center of the circle to the circumference. Now, what I'm going to do is we're going to take it step by step, see what we actually know here. Well, I've been given the answer, the solution for the volume. So the first thing I'm going to write down is actually my formula for my volume of a sphere, okay? So, my volume of a sphere. We know equals to 972 pi. Now I'm going to leave out the centimeters for a moment. Now my formula for a volume of a sphere is 4 over 3 pi or cubed. So that case is equal to 972 pi. Now to work step by step through this, you might pause the video and see can you work from there to find or, but what you're trying to do is isolate or to get or on its own. Now, starting off from here, the first thing you should notice, okay, and we normally refer to this as balancing. What you'll notice is pi is on both sides. Now, what we can do there is divide both sides by pi and cancel each out. So the first thing that happens is them 2 pi's are actually gone. So what I'm left with here is I'm left with 4 over 3 or cubed equals 972. Okay, so that's my first step done there. Now from there, what we should be able to see is we're trying to get or on its own. Okay, so or on its own is our aim. Now, I'm going to leave the cube there for a while. That's the last thing I'm going to deal with. I'm going to first of all deal with this 4 over 3. Now, as we've seen in class multiple times, if we want to get rid of our fraction, we multiply by the denominator of that fraction. So in this case, I'm going to multiply this side here by 3. So my denominator is 3. Now, if I multiply one side by 3, I have to do the exact same for the far side. So here on the left hand side, 3 into 3 will go once. So I'll be left here with 4 or cubed equals, and I'm just going to pop into my calculator 3 times 972, and I'm going to get out 2,916. Now, my next step here, I have 4 or cubed. Now I want to get rid of that 4, okay? Now that 4 is multiplied onto the or, okay? It's multiplied by the radius. The opposite to multiply is to divide. So I'm going to divide my left-hand side here by 4. Now if I divide the left-hand side, I have to do the exact same thing to the right-hand side here. On the left, 4 into 4 will go once. So here I'm left with r cubed. On the far side, I'm going to say 2916 divided by 4. And I'm going to get out 729. Now, the last step here. R cubed is equal to 729. Now, when we have r cubed, okay, kind of similar to if we had r squared, how do we get rid of that cubed? Well, the opposite to cubed is the cubed root. So I'm going to find the cubed root of r cubed. Now, if I do that to the left-hand side, I have to do the same thing to the right-hand side. Now, what we know, cubed and cubed root is going to cancel. So that leaves me, and I'm going to move over here, with r. The cubed root of 729, I'm going to say is going to be 9, but I'm just going to double check. Yeah, cubed root of 729, pop it into the calculator, is going to give me out 9. Now the last thing for me to do, okay, very last step, we found our radius. The last thing I have to do is to think about my units. Now when we're talking about a length or a distance, it's just going to be units, okay, units to the power 1. In this case here, if we look at what they gave us originally, they gave us centimetres, so my radius is 9 centimetres. And that's my answer there. I'm going to come back up here, going to pop it onto the diagram. So here, my radius for my sphere is 9 centimetres. Now again, I've shown everything step by step. There's a few little tricky steps here that you might need to take your time and look through, okay, or redo the question. Be careful with them. We have our answer here, so we're going to move on to part number 2. Now, in part number 2, I'm going to move over to the far board, we are looking for. So here, get out a highlighter, look at the notes for a second again. They say, the curved surface area of the sphere in terms of pi. So in this case, we're looking for the curved surface area of the sphere. Now, to start off with here, okay, and I'm going to drop a few pens because I have too many things in my hand at the moment. We're looking for the curved surface area of the sphere. Now, if you recall, and I'm just going to point back to the very first board over here, our curved surface area we had previously over on this board, okay, our curved surface area here was 4 pi r squared. Now remember, for a sphere, the entire sphere is the curved surface area. So in this case, the curved surface area, this is the CSA, but it's also, I'm just going to write it below it, the total surface area. So just to remember that. So I'm going to go back over. Now my curved surface area here, as I said, my formula is 4 pi r squared. So that's my formula for my curved surface area. Now here the answer, to leave my answer in terms of pi, so I'm just going to put a little star beside that myself because again I may forget that. So filling it straight in, 4 pi, I'm going to leave pi because it's in terms of pi, times the radius. Now we found the radius in the previous question, here it's 9. So 9 to be squared. Now if it was the case you didn't get the answer in the previous question, or you're saying to yourself, oh God, my answer is wrong. Remember, your examiner cannot dock you for getting the answer wrong here and plugging it in over here, okay? So it doesn't matter what answer you got here, that will be accepted for the second part of this sum, okay? They cannot dock you twice. So here I'm going to plug this straight in. 9 squared is going to give me 81. We have 81 times 4. So here we're going to get out 324. In this case, pi. Now, the last thing and the final thing I need to do there is actually say to myself, am I forgetting anything? Yes, I am. I'm forgetting my units. So my units here, again, have a glance back. It's in centimetres. So I'm going to pop in centimetres. And I have to think to myself, it's area I'm talking about. So if it's area, it's always squared. Last thing I'm doing, just because I want to be nice to my examiner, is maybe underline my answer or just put a little box around it for them. Okay, now that's the end of exercise 4.1. I'm going to take a second, going to wipe off the boards, and I'm going to come back to 4.2 in just a moment. So guys, carrying on with question 4.2. So on page number 84, we're just going to have a quick glance at this question here. So they say, highlight the words curved surface area, highlight cone, and highlight 70 pi. So the curved surface area of a cone is 70 pi centimetres squared. It is the radius of the cone is 7 centimetres. Now I'm going to take a second and just for my own sake, what I'm going to do is I'm going to jot down a little diagram or a little sketch of my cone, okay? Now it's very important that you do that because it just reminds you what the shape looks like and what they're actually looking for. So here is my cone. Very quickly. Now, I'm not an artist, so don't judge me. What information do they give me? So they tell me there. They tell me the CSA, the curved surface area, this part around here of the cone, they say is 70 pi centimetres squared. They say the radius of the cone, the radius would be from here to here approximately, is 7 centimetres, okay? So they give me the radius and they also tell me the curved surface area. Now what do they actually ask me? In part number 1 they say, find the slant height. Now, this is a very important part, okay? And this is a really important question because for those of us who don't know what the slant height is labelled, will not be able to answer this question. Now, it's important for me to point out that from here to here is the perpendicular height, and it's labelled H. From here to here, and you'll see it in your log tables, which you've opened now, is labelled L. And that there is my slant height. Okay, so it's really, really important that I know the difference between the slant height and the actual perpendicular height, because the slant height will be labelled L, okay? So going to come back over here, besides slant height, I'm going to put down the letter L, okay? Why? Because that's what it is labelled. And a lot of people will automatically go, they'll see H, they'll say that's my height, here I go, off I go, and they'll be finding the incorrect thing. Now, what I'm going to start off with here, they asked me to find the slant height. Now, I need to say to myself, well, what information do I already know? Okay, what do they give me the answer for? Now, in this case, as you'll see here, they tell me my CSA, my curved surface area, as I noted down here, is equal to 70 pi. Okay, so that's my curved surface area. Now, what actually is my curved surface area? What's my formula here? So I'm going to jot down my formula here. My formula for my curved surface area is pi or L. Okay, noticing we're very lucky in this situation, the H isn't there. So pi or L is equal to 70 pi. Okay, so pi or L is equal to 70 pi. Now, anything I can fill in, I'm going to fill in. But I'm not going to fill in pi because, as we did in the previous question, 4.1, we were able to swipe them out or balance them out. So I have pi, or in this case, as we've seen over here, is 7. L equals 70 pi. Now remember, we're looking for L. So here, straight away, we could divide both sides by pi, or as we normally say, balance them out. So here, both will cancel out on either side, okay? So I have 7 times L, I'm going to say is 7L, is equal to 70. Now, remember I'm looking for L, my slant height. So here, I want to get L on its own, so I'm going to divide by the number, or the term, attached to the L. Here, I'm going to divide the left-hand side by 7. Now, if I divide the left-hand side, it's really, really important that I also divide the right-hand side by 7. 7 into 7 will go once. 7 into 70 will go 10 times. So here, L is equal to 10. Now, last thing you need to do before you move on to the next question, as I always say, glance back and check your units. Now, you'll see from here, my units is centimeters. So, my slant height, or L, is 10 centimeters. Now, you might take a second and actually, I suppose, plot that on your diagram. So here, L is 10, so I'm just going to pop it in here, that it's 10 centimeters, because more than likely we're going to be using that in the next part of the question. Now, I'm going to move over as far as the next board to do part number 2. Now, we're going to take a quick second, we're going to read part number 2, a continuation of 4.2. So here they say, highlight the word volume and highlight in terms of pi. Now, I'm going to jot this down for myself, just to remind myself in terms of pi, because I don't want to make a really, really simple mistake like that and lose marks, okay? So in terms of pi. So they say, find the volume in terms of pi. Now, the first thing you're going to do for yourself, and I'm going to do for myself here, is we're still looking at my cone. So I'm looking for the volume of the cone. So the first thing I'm going to do, and I'm going to get stuck in a second, is I'm going to write down my volume of a cone formula. Now, volume of the cone is 1 over 3 pi r squared h. So 1 over 3 pi r squared h. Now, I can start filling that in straight away for myself if I want, okay? So I can start filling it in. So 1 over 3, nothing to fill in there. Pi, it says leave it in terms of pi, so I'm just not going to do anything there. Or if I come back over here for a second, and glance is 7 to be squared, and then lo and behold, I'm stuck. I don't know what h is, okay? So in this case, I have no clue what h actually is. Now, we're going to step back to the previous board and look what h actually is, okay? So what are we talking about when we're talking about h? We're talking about the perpendicular height to the base. Now, I mentioned this, I think it was in lesson number 2. What you'll notice here, or lesson number 3, apologies. What you'll notice here is this is your right angle triangle. So what I'm actually going to do, because I know from here to here and here to here, I know that this height has to be perpendicular. So I'm going to come over to the far side of the board and I'm going to sketch it out. And you should be able to see straight away what you're going to be using. Now, coming over here, I'm going to sketch it out for myself. Now, my sketch may not be exactly the same as over here, but you'll get the idea of it. What I know is that this is the right angle triangle. Here, we're looking for this here. This is h, okay? Now, don't get h confused with your hypotenuse, okay? So if you want, you can label it x. So please don't get it confused with your hypotenuse. Here, which is your radius, is 7. And here, your hypotenuse is 10 centimeters. Now, straight away, it should have already clicked inside your head. What we're going to be using here is we're going to be using Pythagoras theorem. We have 2 sides and we're looking for the third. Now, my formula for Pythagoras theorem is c squared equals a squared plus b squared. Okay? Now, take a second and label. C is always the hypotenuse, the side directly across from the right angle. A and B it makes no difference which I label either. So I'm going to label this is A and this is B. Okay, so C, your hypotenuse, that's the one you need to be concerned about here. I'm going to fill it straight in. Here, C is going to be 10 to be squared equals A, which is 7 to be squared, plus B, which is H to be squared. Now, here what I'm going to do is I'm going to have 10 squared is going to give me out my 100. Equals 7 squared is going to give me out 49 plus H squared. Going to take the 49 and bring it across the equals to sign. So here I have 100 minus 49 equals H squared. Now 100 minus 49 is going to leave me with 51. Equals H squared. Now, what I have to do is get H on its own, so I don't want to get that square root. Or I don't want that square, so I get the square root. I get the square root of both sides. Square root of both sides, square and square root is going to cancel, so I'm going to get my square root of my answer, which is 51. So here, I'm going to write it the opposite way. H is equal to, and I'm going to go to 2 decimal places, 7.14. Okay, so here equals to 7.14. Now they didn't ask me how many decimal places. They didn't mention anything there about decimal places, how many they actually needed. So I'm just going to go to 2, and remember this is centimeters. Now, finally, once I have that found, I've now found H. I could come back over to this board here and label it in if I wanted as 7.14, and I can fill it in here. So make sure you go back, you fill it in step by step. So here, this is equal to 1 over 3. Now again, they asked me to leave it in terms of pi, so I have pi times 7 squared, which is going to give us 49. And finally, the last thing here is H, which we just found, is 7.14. Now take a second, plug it into the calculator, make sure you don't plug in pi. It's very important to make sure you leave it in terms of pi. So I have 1 over 3 times 49, or 7 squared, times 7.14. Going to get that out. What I get as my answer here is 116.26, or 62, apologies. That's going to be pi. And then finally, I look for my units. I'm looking at the volume here, so it's going to be centimeters cubed for my volume formula here. Now guys, that is the end of our fifth lesson actually. They're flying. So end of our 5th lesson. What we're going to do next is we're going to have a little look at trapezoidal's rule. Okay, so in our next lesson. So I'll see you guys then.